For Chapter 4, one of the topics was greatest common factor. And most of the time you can just do this by looking at the numbers. For number 10, it's pretty easy to see that 3 is the greatest common factor because 33 only has 4 factors, 1 and 33, and then 3 and 11. And we know that 3 is also a factor of 9. Same thing with number 11. 22 only has 4 factors, 1 and 22, and then 2 and 11. We can rule 2 out because 121 doesn't end in an even number, but the square root of 121 is 11. So the greatest common factor of the numbers 22 and 121 is 11. Now on 25, maybe you can just look at those numbers and know that 15 is the greatest common factor. But another method we talked about is just simplifying it in smaller terms. So let's just say I knew that 5 was a common factor. 5 goes into 15 3 times, 5 goes into 45 9 times, and 5 goes into 90 18 times. Oh, and now I see that I can also take out a common 3. 3 goes into 3 once, 3 goes into 9 3 times, and 3 goes into 18 6 times. Now, with those 3 numbers left, 1, 3, and 6, there's not a common factor that I can pull out. And so the greatest common factor is what's here on the left, 5 times 3, or 15. For number 13 and 14, writing each decimal as a fraction or mixed number. Remember, you can start by just saying the number or the decimal the correct way instead of just 0.45. In this case, 45 hundredths. And of course, we can reduce that. 5 goes into 45 9 times, and 5 goes into 100 20 times. So 9/20ths is the answer. 0.375 is one that you should have memorized. It's 3/8, but if you didn't know that, again, 0.375 is 375 thousandths. And of course, you can reduce that all the way down to 3/8. For number 15, ordering from least to greatest, it helps if they're all in the same form. So for 3/10 we have 0.3, and for 1/3 we have 0.3 repeating. So the smallest is 3/100ths, and the next smallest is 3/10 or 0.3. The next smallest is 0.33, and sorry, not the next smallest, the next greatest. We're going from least to greatest, and the greatest of these is 1/3, which is 0.3 repeating. For number 16, I know it's going to be 12 point something, and for number 17, I know it's going to be 8 point something. Well, 3/5 is one that I have memorized. It's 0.6. If you don't have those memorized, you have to do it longhand. 3 divided by 5, which is 0.6. Same thing with 5/16. You're going to have to take 5 divided by 16 and do that longhand if you don't have it memorized. And what we get there is 0.3125 for that. So just really quickly here, 48, and then we have 20, which is 1, which is 16, and then 42, which is running out of room right here. So 32, I believe, and then we get 8, and bring down one more 0 for the 5. So 0.3125 is 5/16, but you might have to do that longhand if you don't have that one memorized. For solving equations that involve fractions, still remember to show that work. It just is really helpful to correct and find out where you're making your errors. You still need to have a common denominator, so we have 3/10 plus 8/10, which is 11/10. I would count that as correct. You could also go one step further and do 1 and 1/10. For number 19, the way you show your work on that is to multiply by the reciprocal so that you can get those numbers to cross off, and just as long as you do it the same on both sides. So we have 16 over 1 times 7 halves, and I can cross cancel there. We should get x equals 56. And there's a couple of different ways that you can do number 20. You could simply minus 3 1/4 minus 3 1/4. Whoops, 3 1/4. It's kind of sloppy there. Sorry about that. Minus 3 1/4. And of course then we have the need for a common denominator. But another thing you could do is take 3 1/4, which is 3.25, take away 1 2/5, which is 1.4, and you get 1.85. But there's more negatives because you're subtracting the 3 1/4. So that may or may not make sense to you, so I'm going to show you one other way. I'm going to say x plus 3 1/4 equals 1 2/5. I'm going to change them both to improper fractions. So we have x plus 13/4 equals 7/5, and then minus 13/4 minus 13/4. And we do need a common denominator when we're subtracting, so times by 4 we get 28/20, times by 5 we get 65/20, and so when we subtract there we get x equals, I think, negative 37/20, which could be reduced to, if you wanted to, x equals negative 1 17/20. However you prefer to do that, that's the answer. Notice up here that 1.85, that should have been a negative, that is equivalent to this as well. So pick your strategy and just remember those fraction rules when you're adding and subtracting. Make sure you have the common denominator and watch for the negatives. On the last one here, I also will show 3 different methods. It kind of depends on what you want to do. 3 3/4 minus 2 7/8. One way you could do that is find a common denominator, which is 8. So we have 3 6/8 minus 2 7/8, and we can't subtract. I see lots of students taking 3 minus 2 and then 7 minus 6 and getting 1 1/8, which is not correct. When you subtract fractions, you do have to borrow from the whole number if the fraction's not big enough there. So I'll borrow and make that 2. And when I borrow, I'm going to borrow 8/8, which makes this 14/8. And 14/8 minus 7/8 is 7/8. So that's one method. A second method would be to change those into decimals. So 3 3/4 is 3.75, and 2 7/8 is 2.875. And when we subtract that, we get 0.875, which is the same thing as 7/8. So that's a second method. And then the third method would be to change to improper fractions. So 3 times 4 is 12, and plus 3 is 15/4. And then here we have 16 plus 7, which is 23/8. And if we multiply by 2 to get the common denominator, we get 30/8 minus 23/8, which again is 7/8. All 3 the same answer. Any one would be acceptable. You have to just choose which method works best for you.